welcome again to another video. So in this video, in today's NewtonGATE concept clearing classes, we will be discussing a very interesting topic, and that is probability. So even though we don't know, even though we are starting this topic, later on in the video you will see that we are always talking about this topic. Probability in day-to-day life is very common. Now, how is it related with mathematics? So students, please follow this video very carefully because this is a very interesting as well as a very important topic. So in this video, I will be talking about the concepts that we have mainly in class 8, but it will sure be helpful for you for higher classes as well. So without further ado, let us straight move to the video. Before starting, let us take the cases of these three students. Now, as you can see here, all the students, they have just come out after giving the examination, and we have asked them the question, the most anticipated and the dangerous question that can be asked to the student, and that is, how was your exam? Now, the first student was very honest in his reply. He said that, I haven't done so well. I might not pass the exam. The second one was kind of confused. He wasn't sure how he has done. Maybe he has missed some of the questions. Some of the question he has just, guessed and written. So he isn't sure. But the third one is very ecstatic and he is very happy that he has done well in the examination. Now, on the basis of their expression on their report of the examination, we can say that the chances of passing for the first student is very low, whereas the chances of passing for the third student is very high. So this is all about probability. The concept of probability deals with how likely an event or is something is going to happen in our life. Suppose taking the tossing of a coin. Now, when we toss a coin, what do we get? There are only two possibilities. Either you are going to get a head or a tail. But are you sure while throwing the coin which one you will be getting? No, right? So yes, although we don't know what are the chances of getting each one of them, but one thing is very sure, we know that either we are getting a head or we are getting a tail. The common terms that we generally use while expressing the chances of probability is impossible, probably, likely, chances and certain. Now, with the words also you can see that it ranges from impossible to certain. Impossible means, as you know, it is very difficult to happen, almost it is not going to happen, whereas slowly it is coming to the point where we are actually sure that the event is going to happen. Probability does not tell what will happen, it just indicates the chances. Now, what do we mean by this statement exactly? So for this, I would like my students to imagine this situation. The field, the entire stadium is filled with the crowd cheering for the Team India. The sound is echoing through the stadium and the moment for everyone is waiting for is the toss. Now, when the person tosses the coin, both the captain are not sure whether they are going to win or lose. One of them chooses the tail, one of them chooses the head. So the entire stadium along with the person who is tossing the coin along with the two captains are eagerly waiting for the result. So at this moment of time, no one in the stadium knows what exactly is going to happen, what exactly is going to be the final toss. But one thing is for sure, everyone knows that either one of them is going to get the head and win, or the other is going to get the tail and win. So either head or tail. So this is what exactly probability is about. Probability will never tell you what is going to happen. It will just indicate you what are the chances of that thing to happen. Suppose, for example, imagine the weather. The weather, if it is cloudy, it will just say you that it might be raining. No one is confident that it is sure to rain. So this is about probability. Again, so here I have taken some instances where you can relate with probability. The first one is an impossible event, that is no chances of happening. The second one is a dice. Now in a dice we have 6 faces and each of these faces have their own numbers written on it. Now each one of them coming out during the play has a 1 in 6 chances. Either 1 will come or the 2 will come or 3 will come or 4 will come or 5 will come or 6 will come and so on. Even chance means that there is 50-50 chance of the event occurring. So the next is taking a blue ball out of this 5 collections of balls. Now as you can see, most of them are blue balls, so it is highly likely that that event of taking a blue ball is going to happen. So here as well we can see that probability is never telling us what is going to happen. It is just indicating that how much chances of a particular event is going to happen. So it ranges from no chance to certain. With examples we have taken, we are going to discuss in which case what is happening. Like for example, for no chance I have taken a cat will give birth to the rhinoceros. Now we all know it's a very funny event, that it's never going to happen. We know. Even though someone is coming you and saying you know that it's not going to happen, so it has absolutely zero chance, no chance at all. But what about snow in Sahara? Well, we know that Sahara is a desert, and being a desert, it's very unlikely that it is going to snow. But can we really tell? Right, we cannot. Because with ever changing climate and everything, we don't know what is going to be in the future. So we can just predict and say that it might somehow, someday, might snow in Sahara. So it has very low chances. Now for the tossing of coin, a very common example, we can say that when I toss a coin, it will either land a heads up or a tails. Now coming to the snowing problem. Now Australia is a very cold country. It is very chilly there. So it is high chances that it is going to snow this year too. It might happen that due to some climatic changes or maybe due to the temperature difference, it didn't snow, but it will not remain so. Somehow, as the year passes, it will snow. Again, it has high chances of snowing in Australia. Now, it will get dark at tonight. Now, everyone knows that, all of the students know this, that when it is dark, when it is the night time, it is dark. So we are absolutely certain about this fact. There is no doubt in it. So you can see that with different examples, with different situations, we can relate with chances how they differ from one to other. So try to relate it with a real life example also, because probability is always happening in our day-to-day life. These are the common examples which we will be discussing in our numericals. The coin with its outcome of head and tail, the dice with its outcome from 1 to 6, and our deck of cards with all the 52 cards shown here. Now, for the deck of cards, please be careful about the colors, the different shapes, the different face cards, and what is each of these cards called. Now in general cases, these are the main sums where the numericals are favored. So let us understand them step by step, shall we? But before that, let us understand what is a random experiment and why is it called so. Why random? Chalo, let's give a thought. So, yes, definitely it's a random experiment because we cannot predict its outcome in advance. Now, when you are playing with your sisters and brothers and friends in a game of Ludo, do you really know that the next time you are going to get a 6? No, right? But you do know that you are going to get a number from 1 to 6. So this is why it is called random. Each time you are throwing a die, you are not sure which time what you are going to get. So this is why it is called random experiment, as you cannot predict the result of that particular moment from advance. Here with some examples we have shown you the different types of random experiment that can be taken. So next is the outcomes. Now after the experiment has been done, obviously you will be expecting some result out of it. So the result of any kind of experiment is called its outcome. Suppose I throw a die and the die here it is showing number 3. So the result of the experiment or the outcome of the experiment is 3. Next we have equally likely outcomes. When each of the outcomes have the same chance of occurring, we say that it is equally likely. For example, getting a head or a tail. Now, what do we exactly mean by that? So, when we are tossing a coin, head as well as tail has exactly 50% chance to come in B. Either 50% chance it is going to be head or a tail. So, this type of outcomes are called equally likely. Sample space. Now, sample space is a very important topic in our probability. So, with the help of an example here, I will be discussing the different sample space, sample points, what is the difference, what is the events, why, how is it different, because students generally come up with this confusion in their mind that why is sample space different from the outcomes, the event, what is the differentiate between the events. So here I will be clearing all your doubts regarding this topic. Now here as usual I have taken the roll of a die as my case. Now as you can see, when I am rolling a die, I have exactly 6 outcomes that can happen. So from 1 to 6, I can get any one of them. There is absolutely no way to say that no, you are only going to get 5 or 6 or 7. Now, what is sample point? Now, all these 6 things were the 6 outcomes were the sample space. Now each individually will become my sample point. So each of the different outcomes when taken individually becomes the sample point. Now next thing, the very important thing is what is the exact difference between the sample space and event. Okay, so this is the confusion that most of the students have. Like what is the exact difference, when does it become an event? So sample space will remain the same for all of the dice. So whenever you are throwing the die, the sample space will be remaining the same. That means the total outcomes is going to be the same 6 things. But the event will be changing. Okay. Just like here I have taken probability less than 3. So this is an event. So when I am taking probability less than 3, I am only bothered about the numbers which are less than 3, that is 1 and 2. So it doesn't mean that the rest of the 4 are not there or they don't exist. They do exist. It's just that right now I am concerned about this 2 and hence this is an event. Okay. So this is the main difference between the sample space, sample point and the event. Okay. Hopefully you have understood the concept. Now with that knowledge, let us take a look at the deck of cards. Now students, I already told you that the deck of cards, each one of them, what are they exactly called, is very important for everyone to know. So basically in a deck of cards we have 52 playing cards and they are divided into 4 suits of 13 cards each. So if you count from first to last, there are 4 different shapes you can see. There is spade, there is hearts, there is diamonds and there is clubs. Now the red color we have 13 plus 13 26 and same for the black colors we have 13 plus 13 26. Each of these different suits are 13 in number. Now another important thing which mainly what happens is the face card. Now by face card we mean this queen, king, queen and the joker. The jack. So these are called the face card. Now please be careful about this because sometimes students say that joker is also a face card. Now joker is not a face card. Joker is a replacement for any card that is lost or is misplaced. Okay. So now we have this are the face cards where practically you have a face there instead of numbers. And yes, they are not considered as 11, 12, 13. They are king, queen and jack. So the cards range from A, which is also known as ace, or the number 1, it is called as ace. Then it goes from 2 to 10 and finally the 11th, 12th and 13th card are the king, queen and jack. And those particular are called the face cards. For each of the different suits they are called the face cards. So probability of getting an event, as you have seen, it ranges from 0 to 1. So one can have a 0% and it will F max, if it has, it will be 100%. So by this we mean that the probability of any event will be ranging from 0 to 1. That is, when it will be 0, it will be impossible event, that is, it is never going to happen. Like for example, in this case is my flying of a pig, and the event which will be absolutely exact, it has to happen, will be 1. So always remember this, it's very important that your probability will be any numbers between 0 to 1. It will never be greater than 1 or be negative already. Okay. So hope it is clear. So any time if you are thinking that yes, I am getting a number which is greater than 1 or it is a negative number, be sure that you have done the mistake. So go back and check again. Okay. Okay. All right. With that we come to the definition of probability, which is the number of ways an event can occur by the total possible events. This is the definition of probability, or it is also known as empirical probability. Like for here in the example I have taken, the tossing of a coin. In the tossing of a coin, head and tail are the two outcomes we have. So the total possible event is 2 and the amount of time while tossing a coin the head can occur is absolutely 1. So the probability is 1 by 2. And same goes for tail, which is also 1 by 2. Now if you remember in some slides before, we were talking about equally likely events. So here you can see that both these events have absolutely 50% of happening. So this is called your equally likely or 50% chance event. Next, I have taken the dice, the good old dice, and we have taken the probability of occurring of the number 3. Now, the total number of times the dice is giving us outcome is 6, and 3 is absolutely occurring one time. So, the probability is 1 by 6. And same goes for the pack of cards. If I take the probability of the times the jack is occurring, so there are 4 jack cards and the total number of cards is 52. So the probability is absolutely 4 by 52. That is all we need to know about the probability concept. So now let us start with some numericals. Now all these numericals are very important for your knowledge, and if you can understand this, you will be good to go for any probability sums, not only for class 8, 9, 10, everything will be clear. So, number 1 to 10 is written in separate slips and kept in a box and mixed well. One slip is chosen from the box without looking at what is the probability of the number of getting 6. Now, before any probability sums, let us see what we have here. So there are 10 number of separate sleeves. So there are total outcomes we have is 10. Okay. Now what do we want? What is the favorable event for us? That is getting the number 6, because we need marks, right? So whatever will be the question given to us, that is our favorable event. So number of times from 1 to 10, the 6 is occurring is exactly 1. So probability of 6 is 1 by 10. This is the number of times 6 will be occurring, or if you want to write in decimals, you can also write it as 0.1. So this is probability of number 6. Now that you have solved, let us see that yes, this is the exact answer we are getting. Here we have the sample space. The event is A of getting 6 from the sample space, and hence the probability is 1 by 6. Sorry, this will be 1 by 10. Now that we have solved here, let us quickly look at this. Yes, the number answer is 1 by 10. You can see that the outcomes were 1 to 10 and the favorable event for us was 6, and hence the probability of getting the number 6 is 1 by 10. Now, let us move to another good example. There were 35 students in a class, out of which 20 are boys and 15 are girls. From the students, one is chosen at random. What is the probability that this chosen student is a boy, second is a girl? So again, same way, first total students is 35, right? Number of boys is 20 and girls is 15. Now, what is the probability that the chosen student is a boy? So, first let us discuss with the boys and then we can go to the girls. Boys. Now, how many boys are there? 20, right? So, probability of choosing a boys is 20. And what is the total number? 35. So, 20 by 35. Now, that is 4 by 7. And in the same way, probability of getting a girl is 15 by 35, and that is 3 by 7. The next question is a question for the balls. Here we are taking these balls. There are 8 red balls, 7 blue balls and 6 green balls. Now what is the probability that the ball is neither red nor green? Now before solving it further, the first thing which you need to know is the total number of balls. Now if we count here, we have 8, 7 plus 6 and that is 21. The event E is the ball drawn is neither red nor green, right? So first of all, see how many balls are red and green. Now if we look at it, if I don't select red, if I don't select green, we are only left with the blue balls. So that means that is what we need. That is what we need for our choice. If it is neither green nor red, then the only option left is the 7 blue balls. Now the total number we have is 21 and the number of blue balls is 7. So the probability of the event is going to be 7 by 21 and that is 1 by 3. Now students, always remember to simplify the terms. It's not necessary, but it is good if you do it. Okay. The next example I have taken is 2 dice are tossed. The probability of the total score is a prime number. Now you must be thinking that why is the number, the sample space given to be 36. So I am taking 2 dice here. So in each of the dice I have 1, 2, 3, 4, 5 and 6. Right? For the second dice also I have the same outcome. Now the outcomes are 36 because if I choose it in that way, for each of these individual numbers I am getting 6 different outcomes. Again for 2 I will be getting the 6, again for 3, and continue in this way we will totally get 36 outcomes in total. So that is why here it is written that NS is equal to 36. Now out of this total scores we have to select the one where the total score will be prime number. Now here are the favorable events I have taken here. If you add these outcomes, you will see that all of them are your prime numbers. So you can count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 in number. The favorable events are 15 in number and the probability of the events is 15 by 36. And this is our final answer. The next example we have taken is the well shuffled pack of 52 cards. Now here you can consider this as a mega problem because I have taken here all the different types of events that are generally given in your examination purpose or generally are asked. Okay. Now remember the total number of cards is 52. Out of this, red colored cards are 26. Same for the black. And each of these suits are 13 in number. Next, 2 of spades, that is the number 2 in the spade suit. Now that card is only 1 in number, so 1, and the total number of cards is 52. Jack. There are 4 jacks and then 4 by 52. King of red color. Now we know that there are 2 red colors, one for the heart and the other for the diamond. Now we have 2 kings there, so 2 by 52. A card of diamond. Now diamond is a suit which has 13 cards, so 13 by 52. It's very easy, students. You just have to select the number of favorable cards you want and divide it by the total number. A king or a queen. So either it can be a king or a queen. So in that way, if we see that there are 4 kings and there are 4 queens. So we total have 8 choices out of 52. So that is 8 by 52. A non-face card. Now if you remember the face cards we had discussed, there are 4 into 3, 12 face cards. There are 12 face cards in total. So non-face card is then 52 minus 12. So if I subtract, I get 40. So 40 by 52. A black face card. That means it has to be either your spade or the club. Now how many do we have? Total here is still 52. A black face card, it means that there are 6 cards. A black card. It is 26 in number, 26 by 52. A non-ace, that means the number 1 will not be there. So there are 4 ace cards. So if I subtract that, we are then left with 48 by 52. A non-face card of black color. Now we have already got the black face to be 6, right? So black face color is 6. Now total black color card we have 26. So if I subtract 6 from that, I get 20. So 20 by 52. Now this is the combination of all the different types of sums that are generally favored for your cards examinations. Okay. The curious case of at least and at most. Now we generally say these terms very commonly in our English, at least and at most. Now how does it come into being in our mathematics? So let us see the case of at least and at most. Now at least means the minimum and at most means the maximum. So here the 3 coins we have tossed together, we are taking, find the probability of getting at least one head and at most one head. Now when taking the 3 coins tossing together, the possible outcomes are 8. So out of this, if I have to select at least one head, that means one head has to be there. Okay, at least means minimum one head has to be there, but it doesn't matter if it is more than one. So minimum one head has to be there. So now if you count, in the first one we don't have any heads, so we cannot take that. But all in the remaining 7 we have head. So that is why we will be taking all the 7 other outcomes here, and that is why the favorable outcomes are taken here. Same for at most one head. At most one head means at max we can have one head. We can have less than one, but we will never have more than one. Okay, so at most one head. So all the outcomes which has more than one head will be disregarded, and we will be left with this 4 outcomes, and hence the probability will be, for this will be 7 by 8 and for this will be 4 by 8. So this is your at least and at most. At least means it has to be the minimum, and at most means it has to be maximum. Okay. With that we end our video, and thank you for watching the video. If you like this video, please like, share and subscribe our channel, and for more details you can visit our website or call us on this following numbers. Thank you.